Okay, so in this example here, we have a plane that is flying 910 miles when it goes with the wind in the same time that it can go 660 miles against the wind. And the speed of the plane in still air is going to be 305 miles per hour. And it's wondering what the speed of the wind is. So the first part is the plane flying with the wind, 910 miles, and then in the same time, it can go 660 miles against the wind. And then another key part is the speed of the plane in still air is 305 miles per hour. So, like all questions that are regarding distance, rate, and time, we're going to set up a distance, rate, and time table. So the two things we're going to have are going to be the plane with the wind, and then we're going to have the plane against the wind. And then again, we'll have our distance, our rate, and our time. Now, some of these things we can go ahead and fill in. With the wind, we know it's 910 miles per hour. And then against the wind, it will be not miles per hour, 910 miles. And then against the wind, it'll be 660 miles. So now we're hitting the part where we're going to have to go ahead and apply the speed of the plane in still air. So I'm going to go and draw a picture below. So let's say I have my plane here. This is the plane. Do planes look like this? No, that's fine though. So if I have a plane in still air, we know that it's going to be going 305 miles per hour. So I'll draw that here. Now, if something is going with the wind, that means it's going to be going faster because if the wind behind it, it's going to carry it on to go faster. So that means I'm also going to be adding on some sort of value right here. And that's what we're trying to figure out, that speed of the wind. So to represent the rate with the wind, it'll be that 305 miles per hour, assuming there was no wind, plus whatever the speed of the wind is going to be. On the other hand, if I'm going against the wind, that will make my plane slow down a bit. It won't be going as fast. So therefore, I'm going to be subtracting some rate from it, from speed from it. So to represent that one then, we'll have 305 minus x. So that's how we go ahead and get our rates, because with the wind, it'll be going faster some amount. Against the wind, it'll be going slower that same amount. And then, using distance, rate, and time, I can go ahead and manipulate that equation here, because distance equals rate times time. We're trying to figure out what time is, so time is going to be equal to distance divided by my rate. So I can take my distance, which is 910, and divide that by my rate, which is 305 plus x, and then the same thing with against, so I'll do 660 this time, divided by 305 minus x. And so, if we refer back to the question itself, it says that they can travel those distances in the same amount of time. And so that the distances are what they are, we can go ahead and set our times equal to each other, because again, they're going in that same amount of time. So now I will just have 910 divided by 305 plus x is equal to 660 divided by 305 minus x. And I'll go ahead and I'll cross multiply to solve this. So that will go ahead and give me, what is this? 277, when I cross multiply, 277,550 minus 910x is going to be equal to, let's see, 201 300 plus 660x. So again, I get that by cross multiplying these. I'm going to have to distribute to each one of those in order to get that. And then I go ahead and I solve for x. So that will give me 76250 is going to be equal to 1570x. And then once I go ahead and I divide both sides by 1570, That will leave me with x is equal to about 48.6. So again, let's just double check what the question's asking for. It's asking for the speed of the wind, and we use that x to represent the speed of the wind. So we can say that the wind is going to be 48.6 miles per hour.